Morning, everyone. My name is Ahmed Hisham, Deep Learning Director of Artificial Intelligence Technology Center at Mast University. Today, I'd like to introduce to you our solution in the proposed paper, three-stage applied deep learning framework for COVID-19 awareness, prediction, and diagnosis. This solution won by Academy of Science and Research Technology under under the opportunity of طبق فكرتك, apply your idea. In this agenda, we will talk about problem definition, chatbot system, chest X-ray system, live predictor, how we then deployed these three modules into Android and iOS. First, our problem definition. In 2020, 11 of February, COVID-19 became a worldwide pandemic announced by WHO, which raised a great threat to the whole world. Later on, COVID-19 began to spread all over the world with very, very high and rising numbers. So the need of artificial intelligence and big data analysis to fight the pandemic became very crucial. In our solution, we introduced or we are proposing a three-stage deep learning framework for diagnosis, prediction, and awareness for the novel coronavirus. Our first system, which is the awareness system, it is a chatbot system implemented in Google Dialogflow to announce the cloud-based service for an automatic-based chatbot. This chatbot contained a lot of sentiments like awareness, how to wear face masks, how to wash hands correctly, how to avoid getting infected by COVID-19, and so on. This system, the chatbot system, is denoted as the awareness module. This module contains two sub-modules, which are the English module and the Arabic module. So the chatbot system supports two languages. It also has some sentences like the incubation period and how it's gonna be dangerous to the pregnant. All this data is provided by the WHO. A lot of intents is already included in the chatbot system, like number of cases per day, the incubation period, general information about coronavirus, and so on. We have the second module, which is the diagnosis. The diagnosis module is a chest X-ray system, where the chest X-ray system contains two sub-modules. The chest ray checker module. In this module, we built or we proposed a CNN model to diagnose or detect whether the image or the film is a chest X-ray film or not, which gives more validation to the system. In addition, this module verifies the that the image input to the system is a chest X-ray image. The second one After passing the first validation checker, there is a second submodule, which is COVID-19 chest X-ray model. This is a CNN model to detect or give an initial diagnosis about the highest probability or the confidence score of the appearance of COVID-19 virus or not in the X-ray. Let's talk about the COVID-19 chest X-ray model. COVID-19 chest X-ray model was a binary classifier to detect whether the person is suspected to be a COVID-19 patient or normal person. This module was built in March 2020, where the most of the medical entities was depending on chest X-ray in the diagnosis of COVID-19. However, now the medical entities began to migrate to the use of CT scans, which give more confident scores. For the dataset was provided by 458 chest X-ray COVID patients provided by University of Montreal, 458 chest X-ray for healthy, taken randomly from chest X-ray pneumonia dataset on Kaggle, where the dataset was divided into 80% for training and 20% for validation and testing. However, we injected this dataset in the case of the images of the healthy people to maintain the class balancing, so that the number of COVID-19 patients and the number of non-COVID-19 patients was typically equal number of patients. Here we can find that the test of the chest X-ray for COVID-19 and non-COVID-19 after the CNN VGG16 classifier. After training for 15 epochs, the model was really have an impressive results. There is also the chest model checker that detects whether the model was given an input image of an X-ray or not, and specifically chest X-ray. In this model, we provided a dataset of 6,000 chest X-ray images mixed with COVID-19 patients and healthy, and 3,900 images from scene recognition dataset that's available in Kaggle, so that it's a binary classifier that detects whether the image given is an input image of a chest X-ray or not. And here we can see the concept of our model checker. After a lot of epochs, the difference between the loss and the accuracy is very, very significant. Once we done the X-ray model was built in TensorFlow and deployed in Docker container. Here we can find the mechanism of deploying this model. The live predictor is a predictor that gives the prediction results for the next 5 days at least ahead, where now it is modified to give 30 days ahead. It's inherited totally from time series forecasting model that totally was built up for forecasting prediction model. Since the number of cases of the new cases is always going up and down, uptrend and downtrend. So the best inherited model to resemble this criteria was to inherit the time series prediction. The time series prediction was built up using long short-term memory, as known as LSTMs. It's a kind of enhanced recurrent neural network where this model was tested on Egypt, like we see in our screen. The actual number of COVID-19 patients in Egypt was drawn in the blue color, while the predicted for 5 days was drawn in the red color. Statistically, here is the numbers of the Egyptian COVID-19 prediction. We tested also the model for Germany, and the difference was very, very, very small. We also introduced a new concept in this model, where we created an API that gains the real number of total recorded cases, and once we make our prediction, we calculate the error, then we update and feedback our prediction and our true value to enlarge the data set and retrain the model daily. And here we can see also for USA, where we calculated the average loss for 3 days, and it was 0.78%, which is a very, very low percent in comparison to a trend in USA in June 2020. Same to Italy. Once we done this project or done this model, we need to apply it or deploy it in production. As I've explained before, we deployed this model using the APIs from the worldometers, where it gives the real number of data and the real number of cases, so that the model can update daily and enlarge its data set and train more to give more accuracy. Then the model should be in the hands of the user. So we introduced the mobile application for Android and iOS, where it contains the 3 modules of the chatbot, the awareness stage, the chest X-ray, which is denoted as the diagnosis stage, and the live predictor. And here we can see some screenshots of the Android and iOS integration. Thank you for watching, and hope it's gonna be good.